Hi everyone, Mr. Hamilton here. We're going to look at factors that affect climate change today. And first thing I want to outline as far as factors that affect climate change is I'd like to outline the fact that we have natural causes and anthropogenic causes. What we mean by this is there are some causes that are just naturally occurring in different ways, as we'll see, and then some that are human caused. That we're going to look at as well. And so that is really where a lot of the debate around climate skeptics is. Are the human things that we're doing actually changing the climate? And so we're going to dig into that more in this unit. But this is just looking at the factors, and then the evidence will come as we dig into each of these factors later on. So let's get some definitions up front. One of them is this. What is the atmosphere? Well, the atmosphere is a layer of gas that surrounds Earth. The condition of the atmosphere at a specific time and place is what we call the weather. So taking the temperature, measuring the wind, the precipitation, and the moisture, all of those happen at a certain time on a certain day, over and over every day. And every time we measure that, we call it, this is the weather right now. The weather over patterns, over years, as we compare the weather one day to the day of the previous year, is what we call the climate. It's the characteristic pattern of weather in an area. So how do we expect the weather to play out year after year after year? And if we see that the weather has changed over a number of years, that it's continually getting warmer and warmer every summer, for example, we would say that the climate is changing. But we would not necessarily say that the weather has changed that day. The weather would only change as we measure it throughout that given day. The climate is over a longer period of time as we look at the patterns. Factors that affect climate include the sun. This is actually the biggest factor that affects climate on Earth. The sun heats up the Earth's air, water, and land. The heat produces wind, as we'll look at in a minute, rain, and other features of the climate. And so what you can see in this diagram is you can see that we have, obviously, the Earth orbits around the sun, revolves around the sun. And as it's revolving around the sun, we see that there's certain points for us, January 3rd, where it's at perihelion. That's the closest point to the sun. That would be our winter. So that would mean that our northern hemisphere is tilted away from the sun. And then in aphelion, which is July 4th, we have summer, and our northern hemisphere is tilted towards the sun. So the Earth is, as we know from previous science courses, that it's tilted, and it's going through this seasonal change, and this whole thing happens once per year. The amount of radiation from the sun that reaches the Earth is always changing. It's always changing, and depends on Earth's orientation and movement through space. It also depends on what's happening with the sun. Sometimes there are solar flares that come off the sun that send more radiation our way, or things like that as well. The second thing we're looking at is the atmosphere. This is a second factor that affects our climate. The atmosphere is composed of three main gases. We have nitrogen, oxygen, and water vapor. Now, some of you might be looking at that and saying, well, what about carbon dioxide and methane? I thought those were two gases that are making this greenhouse effect really take hold. You'd be correct, but they do not make up the majority of gases that are actually in the atmosphere. So nitrogen, oxygen, and water vapor do. There are other ones are just trace gases, but those trace gases could have a large effect. The greenhouse effect is a process in which the Earth is warmed when gases in the atmosphere absorb thermal energy radiated by the sun and the Earth. So for example, what you see here is you see that we've got this radiation coming from the sun. It comes into our Earth's atmosphere, warms up the ground. That then emits that thermal energy. Thermal just means heat. If you think about a thermal blanket is something to give you heat, right? So thermal means heat. So that thermal energy is then radiated out. The gases that are in our atmosphere absorb that thermal energy, and then it is emitted by those gases into Earth's atmosphere to stay warm. If we didn't have those gases, all that thermal energy would radiate back into space, but because we have those gases, the thermal energy is kept in our atmosphere, and we're able to be warmer here on Earth, especially overnight when we're not facing the sun. Now that's just analogous to a greenhouse, right? And that's why it's called the greenhouse effect. What would happen in a greenhouse is you have the sun coming in, and you'll notice in the middle of winter you can be in a greenhouse and it can be very warm because the sun is having thermal energy in the greenhouse, and then as the thermal energy tries to get back out of the greenhouse, it's bounced off of the greenhouse walls or the ceiling, and then that continues to stay in the greenhouse for much longer, warming up the greenhouse. The greenhouse effect is a natural part of Earth's climate and helps keep Earth's temperature within a certain range. All right, well, I mentioned that I was going to come back to winds, and this is about winds, and this diagram shows it quite well. What happens is as we get warm air, uh, we know that warm air rises and cool air sinks, right? You probably know that from when you learn how to stop, drop, and roll when you were in grade school, in elementary school. You learn that if you get low, the heat isn't going to be as bad, and you learn that the gases or the smoke will be above you. So that's what's happening in our atmosphere. Warm air is expanding and rising. The wind is then caused because we get these cycles because as the warm air expands and rises and the cool air sinks, you get the cycle happening. Just like when you boil water in a pot, it's the same idea. And that's really the reason we get these winds, because as one comes up and one goes down, you get the cycle and the winds start blowing across as well. Winds are the movement of air from an area of high pressure to an area of low pressure. All wind is the result of an uneven heating on the Earth's surface. And that's because the Earth is striking the surface or the sun is striking the Earth's surface at different angles, and also because you have different gases in different areas. We don't have the exact same concentration of the different gases at all places at the same time. The movement of winds transfers thermal energy and affects ocean currents and precipitation patterns. So all this plays in. That's another large factor that influences our climate. The next one is the hydrosphere. The hydrosphere is all of the water found under, over, and on the Earth. Any water is part of the hydrosphere, and that's why I've given you a picture of the water cycle there. Not that you need to know the water cycle. You've learned that in the past, and you won't be tested on that here. But I just want you to be aware of that every time we see water, that is part of the hydrosphere. Water can absorb a lot of energy before heating up and acts as a heat reservoir that buffers temperature changes in the atmosphere. A fourth factor is plate tectonics. We have known for a long time now that we have these areas that are more susceptible to they're susceptible to shifting because these are all different plates. And right along those plates is where we tend to get a lot of volcanic activity as well. We know that on average they move around 12 centimeters a year, each one of these plates, and there are 12 major plates on our Earth as well. And these are shifting continuously because under the Earth we have a whole bunch of lava that is continually heating up and moving around. The changing of the land affects patterns of air and water circulation, and therefore the transfer of thermal energy. As we said, thermal energy is heat around the world. The moving of tectonic plates also produces volcanic activity. Some volcanoes actually have been known to have their ash in the atmosphere for upwards of weeks. Volcanoes spew ash and other particles into the air. These particles reflect solar radiation and cause a cooling effect. So if they're in the atmosphere for weeks, what's going to happen is the sunlight is not going to be able to get through very well, and that area could really cool down over that short-term amount of time. The last factor that we're going to just look at and consider here is human activity. The modern climate change movement is predicated on the belief that a change in climate is due in part to anthropogenic causes, human causes, right? They wouldn't be outcrying to say stop driving cars if they didn't think that the carbon dioxide emitted from the cars was actually contributing to it. Human activities affects climate change by introducing particles and gases into the air that affect the absorption and transfer of energy from the sun. These materials have been released from the burning of fossil fuels, so the carbon dioxide that gets in the atmosphere primarily. Now, this is all well and good. We've listed the factors, but we still haven't dug into the actual science of it, and we will. Don't worry, we're going to get into looking at modern up-to-date diagrams of this and seeing this. But just so we know, these are the 5 factors that scientists look at when they're contributing how the climate is changing. There are others, but these are the 5 main ones. Hope that's helpful. If you have questions, feel free to email. Thanks a lot. Bye.